Hey there, in this video we'll be looking at the concept of resistance. So if we ask the question, what is resistance? Resistance is nothing but the obstruction to the flow of current in a conductor. So let us consider a conductor. This is made up of a metal. All metals have positive atoms placed at different points within the bulk of the material, and these positive ions are basically the atoms that have lost a few electrons to allow the free flow of current. Those free electrons that are lost by these atoms that are fixed in place are allowed to move about the volume of this conductor. So here I have the positive fixed ions that have formed because these electrons were lost from the outermost shell of the atom. Now, these free electrons that we're looking at move about freely within the bulk of this material. That is, they can move about in any direction that they want. So, when we consider a business as usual case or scenario, these electrons are just moving about randomly. Therefore, like we already saw in the earlier videos, if I consider a cross section, let's say this is my cross section. If I try and count the number of electrons that move in from the right to the left of this conductor and count the number of electrons that move from the left to the right of this conductor, the number of electrons that move over this cross section is equal. That is, the net current across this is zero, right? That's why we said if we take any metal, like say you have some metal in your house and you touch it, you don't feel any kind of shock, right? That is because these electrons are moving about randomly, yet you do not feel any kind of a shock because the net current across any cross section of that metal is zero. What happens if we take this conductor and apply some kind of a potential difference across these ends? That is, say we have a cell and we connect the positive terminal to one end and the negative terminal to the other end with the help of a wire. Let's see what happens. So here we have those fixed positive ions. Fixed positive ions in the sense these occupy some unique points in the lattice structure of this material. Don't worry if you cannot understand what lattice structure is. It is basically the structure, the internal structure of this material. Okay. So these are occupying some unique spaces. Now, I said that we're going to connect wires to these two ends, and I'm going to connect this wire to the positive terminal of a cell and this to a negative terminal of a cell. Under the application of this external potential difference, the electrons that we looked at earlier, so these electrons that we looked at earlier, which were moving about freely or rather randomly, now have some direction that it begins to move in. That is, because of the application of this external potential difference, these free electrons gain energy and start moving towards the positive terminal of the, or rather towards this positive terminal. So imagine all of a sudden you have a lot of people in a closed space and you open the door. What do these people do? They start moving in one direction. Now imagine there are a lot of obstructions to the movement of these people. Okay, so I'm just comparing these free electrons to people moving off a bus when the door opens, and I've introduced a lot of obstructions. So they all want to start moving in this direction because they are negative in charge and they want to move towards the higher potential, that is towards the positive terminal. Now as we imagine these electrons moving in this direction, what happens is they start colliding with the obstructions that they come across. Once they collide with these positive ions, which is nothing but the atoms that have lost electrons. Once they start colliding with them, they will stop for an instant and again start moving towards the positive terminal. They don't only collide with these positive ions, they may also collide with each other. And what happens is the energy that is gained is suddenly lost at one moment, and again it starts gaining energy to move in this direction. So these collisions that take place with these positive ions and with the other electrons themselves is nothing but this obstruction to the flow of these electrons. So this is the concept of resistance. That is, resistance is nothing but the obstruction to the flow of these electrons when they want to start moving in one direction. Now, if you imagine an electron moving, colliding with a positive ion or another electron, it would stop and then again start moving. So, if we try to take a picture of an electron moving in one direction, it would go like this maybe, then it would collide with this positive ion, then stop, then move, then again get collided, again move, etc. Now, there are millions and millions of these electrons present in the conductor. So, if we want to talk about the flow of electrons, we look at it as though it is a drift of these electrons. So, if you would have seen a car drifting, right? A car drifting is quite different than what happens when a car is just moving. So, these electrons are not just moving freely towards this positive terminal, rather, they are drifting towards this positive terminal. The velocity at which these electrons drift towards this positive terminal is known as the drift velocity. So now that we have seen what happens under the case when there was no potential difference and when we applied the potential difference, we can now say that this is how the metal offers some resistance to the flow of electricity, or rather the flow of electrons through it.